so long. So Professor Kim Warren is from the UK. He's part of a company called Strategy Dynamics. Kim is an experienced strategy professional. He's a teacher. He's a publisher of online courses and teaching resources and business modeling. This is fast becoming a mainstream capability for various parties. It's executives, consultants, business students, etc. He also offers resources to help model non-business challenges, notably in healthcare and international aid. After senior corporate strategy roles, Kim joined the London Business School to teach the curricula on MBA and executive programs. To overcome serious limitations with standard strategy methods, he developed the powerful strategy dynamics modeling method for designing and managing strategy for any organization or challenge. Once a specialized skill, building these simulations is now easier, faster, and more reliable than spreadsheet modeling. Such models mimic real-world behavior and performance of businesses and other organizations with uncanny realism. Kim is the author of the prize-winning Competitive Strategy Dynamics, published by Wiley in 2002, a major strategy textbook called Strategy Management Dynamics, published also by Wiley in 2008, and a summary ebook now widely used in MBA and executive teaching. It's called Strategy Dynamics Essentials. It's a Kindle book available from 2011 onwards. Is also the co-founder of Strategy Dynamics Limited, which publishes serious games and online courses exploiting the user-friendly modeling application, Silico. Over to you, Kim. You can unmute and go.
Hearing me okay?
The sound is a little bit soft.
It's up full at my end. Anything to improve that?
Andres, can you hear?
Not at the moment, but I could hear, but it was quite soft.
Second, let me just change the... Hi, is that better?
Yes, that's better. You can go for it.
Much better.
Okay, very good. Okay, and can you see my screen okay?
Yes, screen visible,
Excellent.
audible.
Very good. Okay. Well, lovely. Thank you ever so much for having me talk to your conference this morning. As Nalini explained, I spend almost all my career and all my system dynamics effort in the corporate world, in the business field, really focused on helping businesses make substantial improvements, and the range of applications for system dynamics there is extremely large. It ranges from fixing very local, relatively small-scale problems like we've got a service quality issue. How do we have a better balance between service demand and the capacity and capability of our people to deliver service? So there's a very small-scale local issue right up to very, very large issues indeed, like how do we plan and execute and integrate an acquisition of another organization. And system dynamics it simply is the way to do these things. That there isn't another approach that comes anywhere close to what system dynamics can do to help you fix challenges of that kind. Anything to do with improving performance over time, and system dynamics is going to be almost certainly helpful to doing that. Now, the history of SD in the corporate world is not exactly a happy one. All through the 90s, there was a lot of excitement and quite some engagement by some of the large strategy consulting firms to do system dynamics modeling for client organizations. Some large firms adopted it themselves, so it was used in General Electric, Ford, and some others. But the method got a bit of a reputation for being for taking too long, for demanding far too much time and effort from the stakeholders in the organisations, and to be a bit brutal about this, simply failing to deliver the benefits that were promised. So organisations found themselves putting a huge amount of effort into very complex modelling projects, spending an awful lot of time on this, and when they got to the end of it, they didn't feel that they reaped the rewards from that they'd been promised in the first place. And I think a lot of that came down to the process, the long and complicated and difficult process by which system dynamics models got built. So I've spent quite some time trying to figure out why that problem arose, and eventually came to a different process for building these models, which I now refer to as Agile SD, where you start you start in the same place. You start with a time chart of what the problem is, but then you adopt what is known as an abductive reasoning process. You kind of ask yourself, so why is this number changing like this? Well, this number depends on these two numbers. So a lot of my challenges that I take on are to do with improving profits. Well, where does profits come from? Profits come from revenue minus costs. So you can stick those three things in as the first three elements of your model. They're right. Hello? Yeah.
Are your slides moving?
No, not yet.
Not yet. Okay, sorry.
They will very shortly. If you follow that process through and you stick to the basic principles of how SD works, you can build models relatively fast. They will be validated all the way through as you go, and that they will be quantified and working and give you the answer that you want. So I've adopted that approach to all the modelling assignments I've done in the corporate world ever since, and this particular case concerns a challenge that was brought to us by, this might seem a little bit strange that this challenge would be brought to us by an organisation called the British Standards Institution. British Standards Institution develop a lot of the standards that are promoted and led by a wider organisation called the International Standards Organisation, ISO. You may have heard of quality standards such as ISO 9001. It is the kind of universal, most widely used standard for improving the quality of products and services. So the British Standards Institution publishes really quite a lot of standards, and they basically divide into two types. There are product standards. So if you want to produce, I don't know, a light bulb, for example, the light bulb that you manufacture must conform to ISO standards. But the other kind of standards are what are known as management standards, and they are standards for managing things that you want to make happen in a business, and an awful lot of those are to do with business improvements. The particular business improvement that this is about is the improvement to reduce the energy use and therefore the greenhouse gas emissions that are made by organizations. Now, big companies, big carbon intensive companies are all over this issue already. They're working very hard to drive down their carbon emissions, but small to medium enterprises are not anything like as aware or understanding of how this can be done. So what the BSI wanted was for us to develop actually one of what we call our serious games, to engage the leaders of small and medium enterprises with the challenge of driving down their greenhouse gas emissions. So that is the latest of the projects that we've done for the British Standards Institution. So this particular challenge is one of a broader class of challenges that businesses try to take on, and that is challenges to make business improvements. So we're basically looking at an ongoing business. We're not looking at new ventures here. We're looking at an ongoing business that is performing. It might be performing perfectly fine in sales and profit terms, but it believes it can do better. And the kinds of ways in which it can do better are not necessarily financial. Some are, and some are less financial. So a very common one is to improve the health and safety in an organisation, and that means going through a process of figuring out how to reduce the number of accidents and injuries that your employees suffer. It's not only is that a kind of costly and disruptive thing for your business, but of course it's pain and suffering and distress for your employees. So organisations want to drive down the number of accidents and injuries that their staff experience. Many organisations want to drive down the number of incidents in which they suffer data loss. That it could be data loss for kind of accidental reasons, or it could be malicious. It could be people hacking your systems from outside. So you start with some incidence rate of data breaches and data loss, and you want to improve that. You want to drive that down. Of course, particularly right now with energy costs being so high, you want to reduce your energy use. And if you reduce your energy use, then you're going to be reducing your greenhouse gas emissions. And there are other business improvement things. One of the kind of flavors of the month right now is something called digital transformation, where you believe that your organization is held back by having too many manual or not automated processes. So you look around the organization for opportunities to digitize, automate those processes in your organization, and thus digitally transform your organization. So these are all projects that we've done for the British Standards Institution. So how do the promoters of standards, both ISO, BSI, and indeed people inside organizations who think that adopting management standards would be a good idea, how do they think this should work? Well, at a high level, this is a statement of what they believe. We believe that if you adopt a BSI standard, a management standard, you will improve the problematic issue that the standard is intended to address, but you will also get wider business benefits. So, if you reduce the number of accidents and emergencies and injuries, for example, you'll have better staff retention, you'll have higher productivity, and therefore your business profits will improve. If you cut down on the number of data breaches that you experience, then you'll suffer less data loss, and each of those is costly, so you'll save costs. And because your data is clearly more secure, you'll be able to win clients of other businesses who buy your data dependent services, and therefore your revenue will rise and your profits will improve. So in each case, there are direct benefits for the issue on which the standard focuses, and then there are indirect benefits that arise as a result of that. And it is kind of axiomatic to the people who believe in these things that you will only get this if you have strong leadership. Leadership has got to say, yeah, we're going for this, and we are definitely going to get these benefits, and come with us. We're going to improve our business in this way. And you will only get the benefits if you have staff engagement as well. You've got staff who say, oh yeah, we really want to help drive down the number of accidents. We want to drive down our energy use, and so on. So that's the kind of high level belief among the promoters of standards. But when we started on this, it wasn't at all clear from anything that the BSI publishes how exactly those benefits come about. It's almost a kind of statement of belief, and that there are case studies that say, oh yeah, we adopted this standard and we got these benefits, but it was very unclear exactly how. What are the mechanisms that bring that about? So let's do system dynamics to this problem. Here is the behavior over time chart that we're trying to influence. There is some problem rate that we're worried about. It's the number of illness and injury cases per month. It's the frequency and scale of data losses. It's the amount of energy we use per month. It's the time and cost of the processes that work throughout the business. And that problem rate is believed to be too high. We fear it could stay high, if not get worse. And what we want is we want that problem rate to drive down over time. And we're talking about timescales of kind of 1 to 2 years is the kind of timescale over which these benefits come through. So where does that problem rate come from? The number of actual incidents or the amount of energy use? Well, it comes from some factors in the business that are driving that problem rate. So how many of these problem drivers are there in the business, and can we drive that number down? What do we mean by problem drivers? Well, you get accidents and injuries if you have hazards and risks in the business. So if you've got cables lying around the floor, or you've got slippery stairs, or you've got unlit steps, those are hazards and risks which will give rise to injuries and accidents. You get data loss if there are opportunities for data to be lost, like people carrying their laptops on public transport and not being careful with them, people putting their password on a post-it note next to their computer screen. Those are all opportunities for data loss, and the more of those there are, the more data losses there will be. Excessive energy use, there are things called significant energy uses around any business organization, heating systems, lighting systems, and so on. And each of those and poor insulation is an opportunity to drive excessive energy use. And therefore you have more energy consumption than you would like. And if we go on to the digital transformation, there are business processes out there. The problem driver in that case is the number of business processes that are too manual, they take too much time, they are too unreliable. If we could digitize those, then the efficiency of those processes would improve. So that's what we're looking for. We're looking for those problem drivers, and we want to drive that number down. So there's that problem rate. That problem rate reflects the number of problem drivers that remain. That therefore means that you have taken a number of opportunities to fix things. So you have gone around the business and you've tidied up the loose cables. You have made sure that steps are safe. You've lit the unlit corridors. In the energy field, you've installed the insulation. You've installed the timers on the lighting systems and so on. So you have, when you've driven down that number of problem drivers, that means that you have taken an increasingly large number of opportunities to fix things. Now, in our world, that's a stock, right? It is an accumulating stock. That stock started empty. We have not taken any of these opportunities to fix things. And over the process of going through the management standard, we have taken more and more of those opportunities, and that stock has filled up. Now, for that stock to fill up, so that is the number of problem opportunity drivers minus the number of opportunities that you've taken. For that stock to fill up, this other stock must have emptied, and that stock is the opportunities that you know of but you've not yet taken. Okay, So the stock at the bottom fills up because that one is drained away, so that the total number of opportunities that you found and taken fills up. And that's what the BSI process tells you to do. It tells you to go and find opportunities to make these improvements, and then it tells you to adopt processes to actually implement those opportunities. So how does that happen? Well, that happens because you as management put staff effort onto this. So there'll be some executive responsible for reducing your organization's energy use. There'll be an executive whose responsibility it is to lead the improvements in health and safety. There'll be an executive probably in the IT department who is responsible for driving down the number of data breaches. So right at the start of the standard implementation process, you put staff effort onto this problem. And what the standard does is it gives you management processes for those people to use in order to identify the opportunities. Okay. The documents themselves are a little bit tedious, as you might say, but actually they specify quite clearly the processes that you need to adopt. It basically says you must adopt processes that will find and specify and measure the number of opportunities to reduce hazards and so on. When you found them, you've then got to say, okay, we now know where all these opportunities for improvements are. We've now got to commit money and we've got to commit people to actually take these opportunities. So we have to commit maybe training time, for example, to help your staff understand how to eliminate data loss risks. You have to train your staff and you have to invest money in reducing the number of hazards and risks in the organization. So you're probably wanting to know where all the feedback loops are in this system. And it's well known in the standards world that the more you are seen to fix problems, the more you get staff engagement. Remember I said that staff engagement is critical to making these improvements happen. So the more you actually are seen to make improvements, the more your staff say, hey, oh yeah, this is working, let's see what we can do. And what happens is that staff start spontaneously saying, hey, there's an opportunity here. They come to management and say, hey, look, you know, there's this, I've seen this hazard over here. There's a kind of a sharp corner that someone could bang their head on here. We really ought to fix this. Or, you know what, we're leaking energy like anything in this corner of the building because people keep leaving the windows open. So you don't rely anymore on that allocated executive to lead the process of finding improvement opportunities. The staff start finding them themselves. They bring them to you. I can tell you a case that formed part of the work here. The UK's largest producer of chicken and chicken-based food in the UK. I think they produce something like a third of all the chicken meals sold in the UK. So it's a really big business. They do everything from hatching the eggs to packing the ready meals made from chicken. And the energy executive in that business explained to me that over 2 years they had driven down their energy use by 40%, 40%, in under 2 years by looking for the opportunities to save energy, by taking those opportunities and delivering that. Now, she said that actually that they've only started on their energy saving opportunities here because they haven't done the next thing, and the next thing is to actually spend the money that you save by making those improvements on taking even more opportunities. So this company, a company called Avara Foods, has made all of those 40% savings without spending any significant money. It's basically been really simple things like making sure staff know to keep the windows closed, turning the temperature down by 1 degree, fixing leaks in their air compressors. Air compressors are huge consumers of energy. Some very cheap, so they spent little bits of money on things like putting timer controls on some things that were otherwise not timer controlled. So there's your second reinforcing loop there, which says spend the money that you make from the initial benefits on making more benefits. And of course, eventually you run out of those opportunities, and that's where you have a balancing loop. So you'll notice that we've got that classic kind of S-shaped improvement path on the number of opportunities taken to fix things. Well, that happens because basically you just run out of opportunities. So it gets harder and harder to make the case for spending money on saving energy because you save so much energy already. The scope for the next opportunity to save still more energy is reduced. So we run out of opportunities to find that. So here are 3 games to show how management standards drive business benefits. I've shared these slides with Nalini. There's a link in those slides which will take you to the page with each of these 3 serious games on it, and when you play those games you will see that structure that I just described is laid out, and what the players of the game have to do is they have to decide how much staff effort to allocate to implementing the standard, and then they have to decide how much money to spend, and then the game plays through the amount of benefits that come about. So that these games feature on the BSI website, and they are aimed at small to medium enterprises to encourage them to start using British standards. But the one that we're really focusing on here is this game that we built to help SMEs drive down their greenhouse gas emissions. Now, this is being promoted by the British government's Department for Business and Industry. They are very keen to get SMEs to start on this effort and drive through energy reductions and greenhouse gas emission reductions. Why is that? Well, businesses in total account for 18% of UK emissions, much more if you add in the transportation that they employ. Half of those emissions come from smaller organisations, and SMEs are defined here as businesses with up to 250 employees. And just to set this in context, employment-based emissions are about 4 tonnes of CO2e per employee per year. Now that is very close to the global average of total greenhouse gas emissions. So if you take global greenhouse gas emissions and you divide it by the world's population, it is about 4 tonnes per person per year. So in the UK, each employee from their employment alone is generating about 4 tonnes per year of greenhouse gas emissions. That's getting to work and all the energy that's used by the companies that employ them when they get to work. And regulations and business customer pressure increasingly demand action to cut emissions. So if you are a small business supplying larger businesses, the larger businesses themselves have an imperative to drive down their greenhouse gas emissions, and you as a supplier are part of the greenhouse gas emissions that they are responsible for. And against that context, the understanding and action among SMEs is extremely low. So very few SMEs understand about their greenhouse gas emissions, and very few are embarked on this process. So this is a rather different style of game. It's called the Net Zero Challenge for SMEs. Again, you can go to this game at the link that I've shown there. And the way it works is as follows. It basically puts you in charge of an SME, and it says, let's start on this challenge of driving down greenhouse gas emissions. Now, those emissions come in 3 types. There are what we call scope 1 emissions from burning fuel in the business itself. So if you've got a boiler burning gas to provide the heating in your building, the gas that boiler burns is generating Scope 1 emissions. If you have a furnace for curing plates that you're manufacturing, then the gas that furnace is burning is a Scope 1 emission. It is energy consumed inside your business by burning fuel inside your business. If you have a transport network of vehicles, then the diesel that those vehicles burn is Scope 1 emissions. Scope 2 emissions is emissions that arise because of energy you use that you buy in from outside. So basically that's driven by the electricity that you use. If you burn electricity somewhere, there is a power station that's burning gas or coal, and that power station is generating emissions. So it's not, the emissions are not made directly inside your business, they are made by an energy provider from outside your business. And Scope 3 emissions are emissions that arise either upstream of your business by the suppliers who supply you with goods and services, or downstream. So when you produce a product, then do the people who buy and use that product, do they then produce greenhouse gas emissions? So one of the case examples here is a company that manufactures pizza ovens. So that company produces quite a lot of greenhouse gas emissions to manufacture the pizza ovens, but a much bigger number is the amount of gas that is consumed by the pizza restaurants that buy those ovens and use them to cook your pizzas. Okay, so that's called Scope 3, and a big piece of Scope 3 emissions is the emissions made by your own employees getting to work with their commuting. So when they commute by car, then the greenhouse gas emissions that they use when driving to work are Scope 3 emissions. So organisations need to drive down all three of these. How do these emissions arise? Well, for all kinds of business, the baseline emissions are basically driven by the space that are occupied by your employees. So if you're a hairdresser, then you have to heat your hairdressing salon. All right. If you are a restaurant, you have to heat or cool your restaurant. If you're a manufacturing business, you have to heat or cool the space in which your employees work. So this is a big baseline driver, regardless of what kind of business you operate, unless it's a completely online business, of course. Typical space for an office-based business is about 10 meters squared per employee. Some business types use more space. So if you've got a very large manufacturing process, you might have very few employees per 1,000 square meters. Going back to our hairdressing salon, if you've got a hairdressing salon, it's a relatively small amount of space per employee. So the more space per person you need, the more energy use per person there is. In addition, so that applies to office-based businesses, to consumer service businesses, to manufacturing businesses. Those are the big three categories of business that we're looking at here. In addition, if you operate a consumer service business and you prepare food, then preparing food is a big driver of greenhouse gas emissions. If you are a manufacturer and your manufacturing process consumes energy, then that adds to your greenhouse gas emissions. So when you start off, you choose which kind of business you want to pretend to be, and what side you pretend which type of business you want to be. If you are a consumer business, it says how much food preparation do you do. If you're a manufacturing process, it says how much energy do you use on your manufacturing processes. And you're then presented with this screen, and the top bar on the left there is the build-up of the amount of energy and greenhouse gas emissions that you produce from heating, from cooling, from lighting, from food preparation in this case, and from other energy uses. So you've got that kind of stacked bar that says this is where you're starting from. After you've made some improvements, you get to to the middle bar there, which is the current rate of greenhouse gas emissions. And if you reach best practice, then you get to the third bar, which is a much lower rate of carbon emissions, something like 60% of what you started from. However, you can do even better than that. So the middle bar can get smaller than the bottom bar. So you get even better than current best practice. We had some professional.
You five minutes left.
That's lovely. Yeah, thank you. Yeah, I'm nearly there. And the way that this works, we have to remember that people we're talking to here, they don't understand anything about system dynamics. They don't understand anything technical. They are general managers who don't have any technical background. So we were helped by some designers that BSI connected us to, and they said, well, let's put this in a much more intuitive way. So they said, rather than say to people, well, you're spending X thousand pounds on this and you're using Y thousand kilowatt hours of energy, let's say that there are some big expensive and time-consuming opportunities. So replacing your entire heating system with a heat pump, for example, is very costly and very time-consuming. So let's say that is a 3-token opportunity in terms of cost. We're not going to specify exactly what the cost is, but it's big. And then there are small ones. So the ones you're looking at here are 1 token in terms of cost and effort. So making your staff aware requires little cost and effort. Turning down the heating by 1 degree consumes little cost and effort, and so on. So this runs in 6-month periods, and for each period you've got a certain number of tokens that you can spend. So in this case, the player has got 3 tokens left, and they have already decided in this round that they are going to lower the heating by 1 degree. So you pick the opportunities off. There are 3 tabs there for 1 token opportunities, 2 token opportunities, 3 token opportunities, and then you say, okay, let's implement that and go for the next period. That you spend those tokens, and when you get to the end, you're presented with this chart that shows what's happened to the total greenhouse gas emissions from your business. So the light blue trend line there shows how much you have reduced your greenhouse gas emissions through the choices that you made, through your spending of those tokens over those 6-month periods, and that number can continue to fall a little bit after the 2-year period because some of those benefits continue to roll through. The dark bar there says, while you are doing all this, the UK is gradually changing its energy supply towards renewables. So we are closing gas-fired power stations and we are switching to offshore wind and solar sources of power. So even if you did nothing, your carbon footprint would gradually fall because the energy that you're consuming, that scope 2 energy that you're consuming, is increasingly coming from renewable sources. So that's where that comes. So that's the kind of end screen, and then you're kind of led on to your strategy plays out over 2 years. There's the 5-year impact of your work. There is the further impact of the UK switching to renewables and nuclear. And just so you understand that there is a system dynamics model lying underneath here. Here is the piece of the underlying model that actually identifies the number of opportunities against all of those uses, and there is an outflow for those, which is capturing your actual rate at which you are implementing the opportunities to save energy, and you're seeing the lower rate of energy use. So each energy use opportunity is actually an energy using asset that can either be used less, or it can be made more efficient, or it can be stopped altogether. Right? All of this relies on those underlying fundamentals of system dynamics I mentioned at the beginning. We want to improve performance over time, performance in every period, in this case energy consumption and greenhouse gas emissions, is driven by the quantities of stocks that drive those performance outcomes. Those stocks can only be changed by flow rates, and those flow rates depend in every period on existing stocks, on decisions and external factors. That causes interdependence and feedback, and drives that's the core of the system that drives performance. And the case we now make in every business application of this is that there are no exceptions to this. This is a universal truth of how any system actually works. And this is, if you follow this process, this is the agile approach to building SD models. I'll leave you to read this in your own time. There is a kind of universal architecture that describes the structure of many businesses, and this is the agile SD process, which is explained in our courses. So I think that's the end. That's the end. Yes, it is. So we stop there.
Thanks.
Hi.
Thanks a lot. Sure. I don't know where's the screen from. Thanks so much. I think that's been an excellent presentation, and I mean, I think gameplay is the best way to actually understand and change mindsets, understand systems in a way that you don't even realize you're actually learning something.
Yeah.
So we do have a question for you from Corné. Corné, you can just switch your mic on and then go for that.
Thank you, Noni.
Hello,
Thank you.
Corné.
Hi, Kim. Thank you again for the presentation. Like Noni said, also appreciate the serious games aspect and the investment you've made into the adoption of SD and why the problems really lie. My question is regarding the standardization. I think what I've seen often is in places where there's extreme firefighting or chaos, people still think adopting the standards will create benefits and they actually don't. So my question is, why do you think in cases like those, does standardization not actually lead to benefits? And why are so few people actually talking about that disconnect?
Well, I think that question really should be most addressed to the British Standards Institution itself. But from what I've gathered by working with them over the last 12 months on this, you're exactly right that there is considerable skepticism in some organisations about the benefits that come from standards. Other organisations are absolutely committed to them and enthusiastic advocates of how powerful and useful they are. But you're right, there are organisations that have tried it and say, oh, that doesn't work, I'm not going to bother. We put lots of effort in and got nothing out of it. But it comes back to the two things that the BSI itself highlighted right at the beginning, and that is management leadership. If management really do believe that standards can improve their business, and they make it very clear to their employees, we are doing this, right? You may be skeptical, but we are going to do this, and we want you to join us in this journey and work with it. So quite a lot of failure cases can be kind of traced back to management's that they kind of talk the talk, but they don't walk the walk, if you see what I mean. They say they're enthusiastic, but then they don't follow up by actually committing the time and effort to do this. So they appoint somebody to be responsible for cutting their greenhouse gas emissions, but then they don't give them the time, they don't give them the access to the operation parts of the business that they need, they don't give them any budget to spend on fixing things, they don't set up training time for their people. So it's a failure to follow through, really, that I think is most commonly the cause of failures for standards to be adopted and to deliver the benefits that they could deliver. In other cases, the potential benefits actually may not be that great. You know, if you're not a data intensive business, then you may not be suffering any significant harm from data breaches and data losses. So if you adopt that particular standard, maybe it won't deliver any benefits for you. So I think those are the two kind of candidates for things not working out.
Thank you so much,
Right.
Kim.
Thanks a lot, Kim. There's just one more. Due to time, we'll just take this one. There's a question from JP McCown. What software tools do you use to create the online games?
Okay. So I had a software tool developed specifically to support the Agile SD method. It's called Silico. I'll just put that in the chat. Silico. Silico.ai is the link. And it has a couple of features that are absolutely critical. First of all, it presents every variable in the model presents both actual data and simulated data alongside each other. So wherever you are in the model development process, you always know whether your model is matching reality, because you've got reality alongside simulated results on the same chart in the same model. The software displays time charts by default on every item, and stocks and flows are explicit. So those are the kind of three criteria. So Silico AI it's an online app. It's not an installable. It's extremely intuitive to use. It's a fantastic teaching tool, because you can get people building useful models in a matter of minutes with it.
Sorry,
what we then
thanks,
have
Kim.
to do, what we then have to do is take the code out of that and put it into a web interface for that purpose. And only kind of just make one very last comment, that this model is accessible and usable by anybody. So anyone who's got any interest in helping organizations drive down their greenhouse gas emissions, please share this model with them. It's open access and anyone can use it from anywhere.
I think what we will definitely do is perhaps for our next conference, or even as part of our events through the year, actually organize a workshop where you can actually take us through the software. I think it is incredibly useful, but not as well known as our other modeling software. So thanks again, Kim.
Okay, good. Well, thank you for having me, and I hope the rest of the conference goes well.
Thanks a lot.